Okay, well, I'm going to share my screen to do a little bit of housework here, if I can find. Okay. Okay, so we want to welcome everyone to the Western Canadian Reason webinar series. And tonight, we're going to learn about logistics and the supply chain. And it couldn't be a more appropriate time to talk about the supply chain because a few weeks ago, my very special cat food from my very particular cat was out of stock. And so for a couple of weeks, she had to have it was medically the same, but she did not like it. So that's one of the offsprings of the supply chain. Of course, the fact that my prescription medication was out of stock wasn't nearly as important as the cat's food. But anyway, but it really is. I don't think anyone has ever thought about the supply chain until COVID, and now with all the stuff going on in Russia. So we do have supply chain issues. But it's going to be presented tonight by, Stephen Sitt, our very own Stephen. We're lucky to have him with us. And I think I remember when Stephen discovered Atheist Society. So I'll ask him about that in a minute. So we are an inclusive community, and we have never had problems with disruptive people at our events. And with your help, we intend to keep it that way. And all of our webinars are free, but we do have expenses. You know, we have Meetup and Zoom and the webpage and all of that. So it's always nice when people donate. Any amount, $1, $5, doesn't matter. And I haven't yet, I will put it in the link in the chat so that you will see the address. But meantime, here it is. You can go to atheistcalgary.ca donate or our regular ASC web page. Just click on the donate button, or you can become a member. I think many of you are members already, and you already know it's only $20 a year. And for those of you who are not members yet, just go to Atheist Calgary and there will be a button to press for membership. And tonight, the way we're going to do it is when we get to the Q&A, if you have a question, just use the raising hand icon, and you'll find that down at the bottom of the page under reactions. And just raise your hand and we'll call on you. We'll ask you to unmute and just ask your question to Stephen. But always remember, if after you've asked your question, please lower your hand so that we know whether or not somebody really is wanting to talk. Okay, so we are very fortunate to have Stephen as a part of our group, because in Coffee Chat, I've heard Stephen talk a little bit about supply chain, and I found it fascinating because I didn't know anything about it before. And also, Stephen is, he's the best when it comes to this. Stephen has, I have to read this because a bachelor's degree in industrial operations and engineering and a master's degree in operations research from the University of Michigan. Go Blue, Stephen! It turns out that Stephen and I we overlapped at the University of Michigan. I think it was my last 2 years were Stephen's first 2 years. So there we were in Ann Arbor, Michigan, and didn't know each other until, we won't say how many years later, will we, Stephen? And so I think we will turn it over to Stephen. If I can figure this out, I will spotlight Stephen. And then we'll turn it over to him and he can enlighten us.
Okay. So Good evening, everyone. My name is Stephen. I'm a member of the Atheists Society in Calgary. So Lois has already briefly introduced me, so I'm not going to burden you with that anymore. I'll go straight into the presentation. So tonight's title is Logistics and Supply Chain Management 101. Well, first question, what's the difference between logistics and supply chain management? Why are there two terms? So I'm going to show you the first slide. Okay, so what's the difference between logistics and supply chain management? So let's go for my very first one. Okay, so I'm going to share this and show this on the screen. Oh, sorry, this is the agenda. I forgot to go about the agenda, but anyway, I'll skip the agenda. I'll go for the second one. So I'll just go right into the first question there. Okay, can you see this one?
Yes, we can.
Okay, so introduction to logistics and supply chain management. So here's two questions. Fill in the blanks with the terms. The first one, in highlighted yellow, supply chain management system. The second one, logistics. So two statements. First one, we are planning to have an end of semester party at the Wickham House. So this is the Student Association at Mount Royal University. The class has assigned Robert to take care of the what? For getting the beer and drinks for the party. Second statement, Walmart is known for its in the business world to have an excellent what, which contributes greatly to the bottom line and success of the company.
Stephen, do you want to move your slide ahead, I think?
Mm-hmm. Okay, so can you see this one, the slide right here? This one right here?
We're still looking at the first one.
The agenda?
The one I see says something about introduction, brief definition.
Okay, so I'm going to the next one. Okay, so I'm going to go to the next one then. Okay, so this is the introduction, and now I'm going to go to the next one, which is this one, and we'll go into we'll share. Okay, can you see this one? The two questions.
No, we can't. Steve, you might have to stop sharing and switch to it.
Okay, stop share. Okay, and then I'll reshare. Okay, so we'll do a share again. Okay.
There we go.
There we go. Okay, so I have to stop share and then share again. Okay.
Yeah.
Okay, so it's a bit of technical hiccup there. Okay, so the two statements here. So you can all see this. Okay, so which one goes? So I'll repeat again, fill in the blanks with the terms, supply chain management system and logistics. So we are planning to have an end of semester at the Wickham House. The class has assigned Robert to take care of the what for getting the beer and drinks for the party. Second statement, Walmart is known in the business world to have an excellent what, which contribute greatly to the bottom line and success of the company. So what do you think? Which one go where? Now,
I'd say logistics for the first one.
That's my guess too.
The first one, okay? And supply chain management for the second one. Right? You are right, Kevin. Why?
Well,
yes, Kevin, why?
yeah, I would say that for the party, you know that you want the beer and drinks, so it's just logistics of how do you get it there.
Okay.
Versus Walmart has all of the stuff and It's a matter of getting the right stuff at the right time.
Okay. I will further to this. So I'm going to show you the next slide here. Okay. So we'll go to the next one, and that will explain what happened. Okay, so here's the next slide, and I'll come back here. So this is share. Okay, so here's the next slide. Logistics versus supply chain management. The unionist view. Okay, so you can see this one?
Yes.
Okay, so there are four circles, four diagrams there. I'm going to blow this up a little bit for you. So what Gavin have just told me was the unionist view. So supply chain management includes logistics. And this is what most of the industry is using today. So this is what we call the unionist view. In some cases, there's an intersection of the set, logistics, and supply chain management. I'm going to stick to the unionist view and take a real example of WestJet so everybody can see what happened here. Supply chain management is what we call the strategic component. Logistics is the tactical component of this. So back in 2017, WestJet has the plan to fly to London. So they chose Gatwick Airport, which was much cheaper than Heathrow. Now, in order for this to happen, by the second quarter of 2019, they were back in 2017 to get the flights to London, which they had no landing right. The first thing is secure landing rights at London Gatwick. That was about 2 years' time. Well, they don't have the right equipment. They had the fleet of 737, which wouldn't be able to fly from Calgary directly to London, which is about 8,500 kilometers straight. They don't have the range. So they leased a fleet of 4 787 Dreamliner from a leasing company to start. Then flight crew recruiting, most of these are internal pilot training because this is the plane they never had before. Then for the airport maintenance place hangar, well, this is a transatlantic flight. So, you know, within Canada, domestic flight, they don't provide food, they sell you sandwiches. But for transatlantic flight, this is real hot meal. So there is contract from Sky Chef, which actually provide meal for them. And then 3 months before the first flight, airport arrival schedule, gate slot, and location has to be handled. And then the flight crew layover in London accommodation, market promotion and advanced ticket sales, that was 6 months before first flight to 3 months. That has all to be done. That is the supply chain management side of it. So that is the platform, or called the infrastructure for this to happen. So you need all this before the green part. So this happens 7 times a week. That is the flight which operates under the control of the gray part. So the supply chain management sets up the whole framework for the daily flight from Calgary to London. So what happens in the tactical part is, well, the aircraft has to be assigned which plane. That has to be ahead of time. All maintenance that is completed. The flight crew scheduled. So the 1 day before flight, they know exactly how many people are on the plane. So catering service, the meal. And then on the day of flight plan, flight crew, flight route assigned. So there are several routes to go from Calgary to London. So which routes do they take? So there's a flight plan. Departure, arrival, gates, time slot confirmed. Then load up and fill up the plane, board the passenger. And finally, the flight. When they arrive at Gatwick, then the passenger depart and the flight crew off duty and into their hotel. But this repeats over and over again between London and Calgary. So this, I hope, explains what is actually the supply chain management part and what is really the logistic part. So this is the framework, and this is the operation, the tactical execution of it. Okay. So I hope that explains much better. So the next one, well, what is inside supply chain management? There's actually a lot of stuff involved there. So I will show you the next one, because really what is inside supply chain management involves a lot of items. So share. Okay, here we go. So here is really what is in the whole thing called supply chain management. These are the core courses at Mount Royal University. So if you come to Mount Royal to study supply chain management, the bachelor degree will involve these. There are 15 courses here from the second year to the fourth year. So the first year is basically the economics 101, statistics, sociology, or marketing 101. So this is the second year on. For tonight, I'm going to concentrate on transportation and physical distribution only. Because if you look at it, it involves inventory management, warehouse management, logistic management, procurement, which is purchasing, international trade law, contract negotiation with a transportation supplier or your other supplier, information technology, e-commerce, which is a big thing today. And we also involve things such as blockchain now, international business, supply chain decision-making, integrated business solution, operations management, project management, and strategic management. So there are the 15 courses at Mount Royal to get your BBA degree in supply chain management. So for tonight, this is actually a very, very wide topics now. Some of the jobs available here are people such as manager of purchasing, procurement, your warehouse manager, trade law, lawyers. This course is actually taught by a lawyer, and things such as systems analyst, computer programmer, all these things, project managers. These are all some of the jobs that are available in the supply chain industry. Okay, so let's go to the next one. The next one is I'm going to go into the next scope of this. So this will be going into explaining the transportation. There are certain things in transportation that we are stuck with, and this is the fun part of it. If you notice in today, every truck or every container, shipping container, is about 8 feet wide. An international standard container on the ship is 8 feet wide, 40 feet long, and 8 feet 6 inches tall. Why is it 8 feet wide? So we'll go back into history. So this is the fun part of it here. Okay, so I'm going into the next slide now. And this will be, so let's go back to my, okay, so I'm going to share with you a diagram right here. So here we go. Okay. So can you see the picture here? There are 4 pictures.
Yes.
On the top is the back end of 2 horses. Okay?
Mm-hmm.
The back end of 2 horses. This was back in Roman times. Okay? So the Roman times chariot, the Roman chariot, the back end of the 2 horses. So here you're looking at a Roman chariot pulled by 2 horses. Here are the wheels of the Roman chariot. So after running on the Roman road, it created the 2 groove right here. So it wear down. If you take at this and go all the way to the Industrial Revolution, so we are going jumped several centuries ahead into the Industrial Revolution. The British, that's where the Industrial Revolution started. They started building railway track because the steam engine came before the motor truck, way before. So started building your railway track. The railway track followed the old Roman road in England. So the two groove right here come on is exactly where the railway track comes. It's about, the two arrows here is about 5 feet apart. But if you measure the inside wall of the railway track, it is exactly 4 feet 8.5 inches, or 1.435 meter. That is the standard international railway gauge today. So in the 1960s, when we started, or further down, the railway carriage, or the railway wagons, they call it in Britain, the width of this, so there's a bit of overhang on each side, is exactly 8 feet wide. So this is where the 8 feet come from. Okay. So now going further down to the next one. So that's where the 8 feet come from. So I'm going down to the next one now. And here is the next one. So I'm going to share this one with you. So here is the truck in the 1950s. So that is the width of the truck, is 8 feet right here, follows the railway. That is your truck. So back in the 70s, when the containers come on, this is the international standard. You've seen this on ship and on railway cars, and it is exactly 8 feet wide. So you can trace this all the way back to the Roman carriage. And we are stuck with the 8 feet wide container or the 8 feet wide truck standard. Now, some of them may be slightly wider. They could be 8 feet 6 inches, a bit wider. But the container is straightly 8 feet wide today. Okay, so that is the part about why we are stuck with this. Let's talk about certain thing on to terminate the terms about supply chain management. So I'm going to go into another slide here. And this is the one. Okay, so here is the diagram. So I'm going to stick to transportation. So we're going to ship something from point A to point B. The top one is the Euclidean distance. Suppose point A is the port of Busan in South Korea, which is very close to Seoul, South Korea. And that's where Samsung shipped their flat screen TV, or LG shipped their flat screen TV from. So this is the port of Busan. The final destination of this large screen TV is going to Toronto, to the big, the store in Toronto. So that will be something like Best Buy in Toronto. The distance here for the Euclidean distance, which is a straight line from point A to point B, is about 8,200 kilometers. That is the Great Circle route. But really, the real distance is not that. So this is when we are talking about logistics, supply chain management into the transportation. So this is the shortest route, the Great Circle route on Earth. But the real reality is, well, the screen TV was shipped by truck to the port. It's put into a container, put onto a container ship, which is Mode 1, and is shipped to Vancouver. It's actually in Vancouver, there's a transshipment because the container was open, it's packed into another container, a bigger one, a 53-foot container from a 40-foot container, and put on the CP rail train, which is Mode 2, and then go to the CP Rail container terminal in North Toronto, and then put on the truck and go to Best Buy. So this is the transportation part of it. And the distance of this is not 8,200 kilometers. This is actually close to 9,000 kilometers in this case. So that is the transportation distance. But if you look further down, there is something called the logistics systems, because it's not just the shipment. You have to involve order processing, packing this, scheduling the truck, and which container ship you go on. And then here in Vancouver, you have to sort the container, open the container, sort out the content, which of those large screen TV are going to the Best Buy store in Toronto, which are going to Vancouver. And some of them may go to the Best Buy warehouse in Vancouver and then put on the CP Rail train and then come to the Best Buy warehouse in Toronto, where they store it temporarily and then put on the truck and then go to the Best Buy retail store in Toronto. So if you look at that, step by step, this is really what happened. From the Euclidean distance to the logistics distance. So you see, when we are talking about these things, there is a lot of things involved, and I'll go on to the next one. From there, from the transportation, I'm going to expand this into the next one. And the next one is about what we call a swim diagram, a swim line, because this is actually more than just that. So I'm going to share this one with you. Okay, so this is the swim diagram one. So here it is, the swim diagram. This is what we call a swimming pool diagram. So what I showed you just now was just this part only. We didn't go into, well, for the large screen TV, where did the parts comes from? Because there are many suppliers, the computer chips, the screen itself, the controller, all these could come from different suppliers. So if you look at this, expand beyond just the blue part, which is the Pacific Ocean, well, it's gone way, way beyond this. And this is all these stages. So this is the swimming pool. You can imagine this is an Olympic swimming pool. The swimmers are swimming from left to right. And the final destination is at the end of this swimming pool. Well, there are raw materials, manufacturing, assembly, distribution, which means the transportation, the warehousing, and finally the retail. And what happens here? Well, there would be resource cluster, because the computer chips, the material, the plastic could come from the Middle East, and then you could have the manufacturing cluster in South Korea. And then the gateway, which is Vancouver, and then metropolitan area is Toronto. And look at this. Well, this could come from a truck. This is on the ship, containers on the ship. This is on the rail, and this is on the pickup delivery truck. And then there are costs involved. So all these things add the value all the way, all these is rather complicated. And so supply chain management is not as simple as you may think, because this swim pool diagram could be expanded quite drastically, because there are things such as payment, bank transfer, letters of credit. All these things flow together with all these. So this is the first part of this. So basically, we talk about the introduction and the definition at this point. Okay, so I'm going to go to the next part, and this is taking you on a tour. As I said, I'm going to talk more about transportation. So I'm going into the transportation part of it and show you the different modes of transportation. Okay, here is a ship. So everybody can see this?
Yes.
Okay, so this is what we call a bulk carrier. Okay, so this is actually a bulk carrier, and I'm not going to spend too much time on the bulk carrier. So this is the head of the bulk carrier. So what is inside is actually potash, and this is one of the oil tanker. You can see when it's empty how high the water line is. So this is in North Vancouver, water conveyor belt, where they ship the potash and sulfur out. So here are piles of potash, and here is a big pile of sulfur for export. Here is a crude carrier. Those are huge empty one. See, the water line is way, way above empty. This is a loaded one. You see the big difference here for oil tanker between an empty one and the loaded one. I'm going to spend more time. We are going to talk more about consumer product. So I'm going to skip, and this is basically one of the container ship. So here is a container ship. So APL is American President's Line, and this is one of the old. This is not the largest one, but this is one of the older one. You can see the container ship. So these are the 40-foot container. Here is a 40-foot container where I'm pointing to. These are the 8-foot one, and each one of these can go onto a tractor trailer or on a rail car on the train. Okay, so this is another container ship, Evergreen. So this is one of their ship that got stuck in the Suez Canal last year. This is a newer one. Okay, and let's go into. Here is a very interesting photo. You wonder how your cars or your SUV pickup truck gets shipped to you. This is at the loading port of how cars are shipped. Cars are shipped by this special type of ship. So there is a ramp. This is the back of the ship. They open up the ramp. When the ship sails, this ramp fold up and cover this altogether. You see inside there are levels of back. This is like a huge, huge multi-level parking lot inside. So you see the pickup truck are being driven in now. And when they are driven in, they have designated parking points there. When they are parked there, actually, they are all tied down on their axle. Because when the ship goes on the ocean, they may go pitch and roll. So they don't want the car to be crashing into each other. So when they ship this inside, I've been in one of these in Vancouver. Actually, it's very interesting how they actually tie down at the axle. Every car is tied down before they set sail. So this is how cars are shipped from overseas. And when they reach Canada, so I'm going to skip this one. I'll tell you what happened. We'll take a look at some of the container ports around the world. So this is the container port in Hong Kong. It's actually one of the most busiest one. They handle about 32 million 20-foot equivalent container, which is about 16 million 40-foot container every year. That's the throughput. So here is at the photo at the dock side. When the ship is on the dock, here is what they call the port container crane, lifting the container from a ship and put it in a tractor trailer. So this is on the dock side photo. And this is another photo. You see, it is very, very, very busy in this port. So these are all the gantry cranes at the port in Hong Kong. And another photo here is the dockside photo from a higher view. You can see the ship, the crane, and here is all the gantry crane. The interesting thing about the port in Hong Kong is there is no railway connection. They depend straightly on tractor trailer. There is no direct rail connection. This is the port in Amsterdam. So this is a good photo of one of the crane. The name of this is called a port trainer, P-O-R-T-A-I-N-E-R. That's the industry standard name. We're getting closer to home. This is the Vancouver container port. So this is Vanterm. The difference here between Vancouver and Hong Kong is Vancouver have direct access to rail. the container can come to ship and go to rail directly. They don't have to go to tractor trailer. So it can come from overseas, unloaded here, and it go to the rail, and it can come over from the rail to Toronto very quickly. So here is another view of another port in Vancouver. It's the Delta Port out in south of Richmond. So this is very close to where the ferry is, Powassan. So here's one of the OOCL container ship. This is older one, all rusted. You see the portainers are here, the railway lines right here, and the railway track actually comes right up here. The railway track actually comes right up here. So the container from overseas, they unload it onto railway cars, and it just pull right from the dock here. So the ports in Western Canada all have direct railway access. Okay, here was myself years ago. So this was a delegation from Hong Kong, the Orient Overseas Container Line delegation. And this was at one of the CP rail intermodal system. So that was me, younger days. So there I was, looking much better in my younger days. And we all have to wear hard hats and show the delegation all the good stuff we have done, how we handle all these things. So we had the foreman, the supervisor, the terminal manager, the representative from Transport Canada. So I took the delegation for a tour of the container terminal at that time. So as part of these are some of the CP rail promotions. So I won't go into it. Okay, I'll skip here it is. So the last one I show you about the cars loading onto the ship. After they were unloaded from the ship, what happened? These are the railway cars that are straightly used for shipping automobiles, whether it is car, pickup truck, or SUV. Okay, so cars goes into this. How they load this? If you look inside, here is a photo I took. When you open the end door, it's 2 level. The car just drive right in, and they can ship on a single of this for a sedan, 6 of them. So if a small car, they can ship up to 12 cars in each of these, up and down. And how do they load them? So this is how you load it. There is a ramp, mobile ramp. So this SUV will be driven up to the upper level. And this rail car, when they are connected, there is a ramp in between. You can actually drive all the way through to the other end. So it's how they ship the cars. And after they are loaded, then the door is locked. The car are like in the ship. They are tied down to the floor of the railway car. They close the door, and then the locomotive, they pull. So sometimes they could pull like 20 of these. Then that's how they ship the cars. Here are containers. So back to the containers. These are the 40-foot container on the double stack railway car. So this is Yansing from Taiwan. This came from a ship. This is actually in the US. And we can show you also when they double stack this container. So these are 40-foot container. At the bottom, these are what we call the 20-foot container, the smaller one. So they can double stack this one. So these all came from the ship onto the rail. So I'm going to skip the bulk. This is a coal train. I'm going to skip those. So this is from the rail to the truck now. So here is a container terminal in northern Toronto. So this is how they lift it from the train and then put it on a truck. These are the type of truck they use straightly inside the terminal. They don't allow the big tractor trailer into this, but they haul this inside, and then the trailer is transferred over to the over-the-road tractor outside the terminal. So here is the over-road terminal tractor. So this is a big container on a 18 axle. Notice this one's actually a European one. It's a Volvo. The way the 18 axles are distributed is slightly different from the one here in Canada. Okay, here is an interesting one. This is what they call the chassis. It's almost like a telescope. So the container could be 40 foot, could be 45 foot, 48, or in fact, 53 foot that we use in North America. Those are not allowed on the ship. But when they put the container on the chassis, actually this thing can slide. The length of this can be shortened or lengthened according to the length of that container. So here is the FedEx, and I'm going to skip this one. This was part of my teaching lesson things for the class. So here is another view of the how you ship automobile. Here's a closer view Union Pacific Railway cars and automobiles. Again, here's another photo of how the cars get in. Okay, so skip this. Here we go into air cargo. So we've gone into the ocean, we've gone to the railway, we've gone to the truck. Here is air cargo. So this is the Cathay Pacific 747 air cargo. And if you look at the air cargo plane, this is a air cargo 747-400 series. Actually, the nose can be open. So it's strictly for air cargo. And that's where a lot of things, if you have rush things, especially if it is high-end, expensive electronic stuff you order, it is all air cargo. In fact, all your cell phones and laptop computers are shipped by air cargos. Okay, they are high-value products. Here is the inside of air cargo plane. This is a FedEx 767 air cargo plane that was in Vancouver. I got the opportunity to go inside and take a look at it. On the floor, they have all these rollers, caster wheel, that you can move the container, air cargo container inside very easily. And then they are tied down before departure. So this is one of the container. This is an air cargo container where your computer, laptop goes into. And this is the FedEx 760. This is actually an A330 Airbus air cargo plane. So this is a European one, an Airbus A330. Now, look at how big they can take. Here's an Antonov, Ukrainian air cargo plane. You can actually put a train inside. This was a photo from taken in Shanghai a few years ago. This is one of the Antonov, and the next one I'll show you. Unfortunately, this plane got destroyed a few weeks ago. It was the Antonov 225, the only plane, the biggest plane in the world, 6-jet engine, the air cargo plane from Antonov in Ukraine. It is an Ukrainian aircraft manufacturer, Antonov. This plane got destroyed by the Russian. Okay, so here is a air cargo. It's also part of the logistics of the military. So the war in Ukraine right now, a lot of the supply, the US and even Canada, because we got a fleet of these as well. It is a C-17 Globemaster 3. This is a Globemaster 3 air cargo plane used by the military. So here I was inside one of this, looking at the back ramp. There's where they unload the air cargo. And here is the pilot's compartment. So here it was the pilot, and you look at it. Here is the tank. They can actually ship 2 of these in one of those. And here's again the control and inside. So air cargo plane is military plane is interesting. One of the things is actually everything you can see. They don't cover anything up. Wire, cables, ventilation ducts, it's all out in the open. As for some reason, military air cargo plane, there's no concern about how it looks. It's not like the passenger plane where you go in, you don't want to see wires and ducts and cables. They save all the weight, all the plastic. They don't need that. And it's a safe reason, because in the case there is any fire, any short circuit, any leak, anything, they will see it right away. And they will handle it, because remember some years ago, there was actually a fire on board a Swiss Air out package code MD-11. There was a fire in one of the wiring. but it was all covered up. Nobody saw it. It's behind the panel. But in the military plane, all these things are out in the open. They don't cover anything up. They can see everything. Okay, so that finished that series on different modes of transportation. So we have different types of transportation and briefly show you how cars is being handled, but there are also many other things, how things being handled in other mode. So we won't go into detail of that. The next one is, I'm going to take you onto a virtual tour. So we're going to go onto a virtual tour of a place, which I took the class to before. So we'll go into that and going into the CP Rail Container Terminal in Shepherd. So we are going to go right onto the ground and see what it is like there. So I'm going down and just to go into the USB drive, and that I have to open up another file here. Okay, there we go. Okay, so we are on the ground right now. So this is the CP Rail Intermodal Terminal at Shepherd. So I took the class over there for a field trip. So we all have to wear hard hats and safety vests. And that was the terminal manager. Gentleman explained everything to us, show us the layout of the terminal. So the students were there and we have safety instruction before we went on it. So here is one of the chassis and one of the containers at the CP Rail Intermodal Terminal. So this was in March a few years ago. Now you can see this is one of the Canadian Tire terminal because the Canadian Tire warehouse is right next to the CP Rail terminal. This is what we call a reefer, thermal cane. So this is a container temperature control. That's where your groceries are being shipped. So it could be fresh vegetables, or it could be frozen product. And later on in my bits and pieces, I'll show you the temperature of all these things, how these temperature control, how it affects your fresh vegetable. So this is what we call the reefer, R-E-E-F-E-R, the temperature control container. So this is the hostler. That is the thing they use inside the container terminal. They don't allow actually the big tractor inside. They use these to haul the container around inside the terminal. And this is one of my students together with one of their driver on one of the huge machine. So the student got to take a ride inside one of these machines. They took the class, the student, and there were quite a few of these. There were about 12 of these machines. So the student got to take the turn to ride around in these things. And they gave us a demonstration of how these were being handled. So you can see here, they lift this from a triple axle trailer. They took it up, they lift it, and actually they put it on, and the hostler right here, this is the chassis right here. They took it and lift it. That's where they stack it for storage. So all these empty containers, they store it 4 high up there for further use. So this was the demonstration. They show it all to us, and then they show us how they put it back onto the trailer, the operations at the terminal. So that was me together with my admin assistant at that time. I got my old CP Rail hard hat with me actually. So that was the class in front of the train, and they show us here, actually they lift the container from the train, and some of my students, and you'll realize how big these things are. So there's a photo of her right beside, and you see the wheel is almost above her shoulder actually. And there we were at the end of the tour, the class photo. So that was a few years ago. We spent an afternoon over there. Okay, so we talked the virtual tour without actually going there. The next part of this is going to be the funner part. So it's called bits and pieces. And I'm going to share some of the things with you. So this is not in any particular order, but it's sometimes general knowledge that would be helpful to you. Okay, so we are going to talk about, there are 3 chats here. So, okay, railroads, okay, to everyone. Okay, I'll address some of these later on. So I'm going to close the chat and continue on with bits and pieces. Okay, so I'm going to go into bits and pieces now and get back to where I was. Oh, the wrong place. Close this one. Okay, close this one. Okay, I'm going into my bits and pieces. Okay, the first one is called cube out and weight out. So this is part of the bits and pieces. Okay, so I'll share this now. Share. Okay, here we go. I got the 4 diagrams here. So if you are going to ship something, you bring in a box, starting from the upper left-hand corner. We have a box here. The box is 1 cubic foot, and your box with the contents weight 1 pound. The courier is going to charge you $60 for the shipment. In this case, the volume of the box equals to the weight of the box, and this is what we call equal. There's an equal situation. But if you go to the courier and bring a box which is 1 cubic foot and your box weighs 5 pounds, they are going to charge you by the volume, 1 cubic foot. You are going to get dinged for $60. Let's say you bring in a smaller box and you put your 10-pound weight inside the smaller box and you go to the courier, you have a weight out situation. They are going to ding you for $60 because of the weight, not because of the volume. Now, let's say you bring in a 0.5 cubic foot box and it weighs 5 pounds. Then you will pay $34 for it. You are equal now, okay? So this is something nice to know. Next time you go to FedEx or UPS to ship something, watch out. We do these type of things are used in transportation, and this is what happened to the trucker. If the trucker is going to ship an entire trailer of potato chips, he is going to be cubed out. He can fill the whole trailer of potato chips, and he will probably have barely about 8 tons of potatoes or even less of potato chips there. But the trailer can hold 28 tons. That's the maximum on that 53-foot trailer is 28 tons. But if he filled it with potato chips, there's no room left. It's only 8 tons. He is cubed out. Say the other situation, if the trailer is going to ship, let's say bottled water or books for, let's say hardcover books for chapters. only about 1/4 of the trailer will be filled. And he is already 28 tons because books are very, very heavy. In that situation, they have a weight out problem. So the best is for a grocery tractor trailer is to ship potato chips with drinks. Let's say canned Coca-Cola or whatever, soft drink. Put them at the bottom and put your potato chips at the top, then you will have equal. Okay, so these are some of the things you will notice actually in transportation we have to deal with. Second thing that's nice to know of is, in fact, in terms in transportation, the best performer and the worst performer, if you are looking at it. The best performer, so this is a log scale on your left-hand side, and this is also a log scale of speed. The darker blue are cargoes, the light blue are passenger. The worst offender is the passenger supersonic plane. The Concorde was the worst performer in terms of fuel efficiency. It is, in terms of log scale, it is 10 here. Compare with the bus or the train is 1. Compare with the ship or the oil pipeline is a 0.1 in terms of energy efficiency. So the supersonic plane, even though they travel at 1,000 meters per second, is the worst performer. The jet plane is about 300 meters per second. That is about 500 knot or 600 miles per hour. The jet plane is somewhere here. The jet plane and the cargo plane. If you go further down here, that is the train, the bus, and the car. The truck is about 100 kilometers per hour. But then in terms of fuel consumption, they are down to here, 0.5. They are much lower than the cargo plane. And then the ship is much further down. So in terms of fuel efficiency, you can see the difference here. And the next question is, in bits and pieces, the capacity we have seen, actually, almost of transportation, actually, how much could they carry? So using the semi-trailer truck as one, so one container, 26 tons, loaded in 140-foot container, 26 tons. Equivalent to so much here, okay? So compare, if this is a train carrying grains, or this is a train carrying oil, how much do they carry? Well, in the train of 100 oil tanker car, it is equivalent to 386 tractor trailer of oil tanker. Those you see pulling up at the gas station is 385 of them. But if this is a container ship, so the older container ship, which is called a Panamax container ship, because these can pass through the old Panama Canal, the new one will be about twice of this. So it's about 4,400 containers, 40-foot container, which is equivalent to 4,400 trucks for a big container ship. Talking about oil and railway car, there's an interesting comparison here. Each railway car, the DOT 111 railway car, can carry about 30,000 US gallon for each one of those, which is about 72 barrel. So actually a 100 car railway car carrying crude oil can carry about 72,000 barrel of oil. The Trans Mountain Pipeline has a capacity of 280,000 barrel. So if you divide that into the train, which is 72,000 barrel per train, actually, every day the Trans Mountain Pipeline is the equivalent of 4 100 rail car train. So if the Trans Mountain is not running, you can actually run 4 100 railway cars to replace it. Okay, it's some of the interesting figure you can see. So this is one of the large container ship, the OOCL Hong Kong. So these are the very, very huge containers they have. And this is another photo of that. So this is the railway car I'm talking about. So this one carries 30,100 US gallon or 720 barrel. So when we say I put 100 of these on the train and I run 4 trains every day, is equivalent to the capacity of the Trans Mountain Pipeline. Okay, here are some of the other interesting things that we can talk about. So the bits and pieces here. The next one I'm going to talk about is this, and I'll show you this one. We may be wondering what happened when I am, whoops, back to me. Okay, so here I am. Okay, back to me. About the EV, electric car. Why are we having so much trouble with electric car? What's the problem there? Okay, so here is one slide I want to share with you. The reason is in the next slide. Here is a slide about energy content of some combustibles. At the very top of it, this is the only one that is not combustible. It's the lithium-ion battery. So this graph shows you chemical energy content of some fuel in megajoule per kilogram. Okay, so it's megajoule per kilogram. And this is the content, how much they can have. For lithium-ion battery in your electric car is only 0.5 megajoule per kilogram capacity. Compared with the next one, wood. If you burn wood, it is 17.51 megajoule per kilogram in wood. And going down to coal, the anthracite coal, it is 30.4. Compare that, it is 60 times of the capacity of your lithium-ion battery. Bunker C oil, which is used in the ship, 41. Going to the jet fuel, they are 44. And your automobile gasoline is 45. It's 45 megajoule per kilogram. Natural gas is higher. LNG is 65 or 55. Methane is very high. And if you were to use hydrogen, hydrogen is 140 actually. But 1 kilogram of hydrogen takes up a lot of space. If you were to use hydrogen, you better be able to compress it, highly compressed. So that kind of explains to you why we are having so much trouble with the rollout of electric car is because the energy content of your lithium-ion battery is actually very dismal right now. Compared with hydrocarbon fuel, right now, there's no comparison. So this is one of the things in our bits and pieces I can share with you. And then we'll wrap up on the bits and pieces. The next one we'll get into is something interesting. I show you the reefer. So the temperature control. And these are some of the temperature. When we ship things, groceries, on a temperature control container, what temperature range are we using? So industry, they have different names for it. So the blue one is something called chill. The chill temperature, the freeze deep chill temperature, the vegetable temperature, there is the banana temperature, and then there is the frozen temperature and the deep frozen temperature. So let's take a look at some of the groceries things you will see. Apple. So if the apple is kept at 0 temperature, it actually has a very long shelf life. Banana, that's why you don't put your banana in the fridge. Inside your fridge is 4 degrees. You want to keep your fridge inside at 4 degrees Celsius. Banana, you want to keep it at 13.3. That's how they ship banana. Vegetables like red green pepper, 7 degrees. These cabbage, eggs, onions, and veggie are very close to the freezing temperature. When you put your eggs at 1.1 centigrade, it can actually last 180 days without freezing them, but close to freezing. Veggie, now there is something called chill and deep chill. Those are just below 0. So fresh meat without really freezing them. Because deep frozen, the meat, the molecules, the cell structure of the meat, some of them get damaged. So they put this as something called deep chill without really freezing it. And you can actually keep the meat for a very, very long time at that temperature. So some of these are vacuum packed. You can keep them for a long, long time. And pears, pear is one of those. There's a finicky one because pears goes bad very, very quickly. So veggie and potatoes, 10 degrees. Then there are something called the frozen temperature. Minus 18 degrees is where your frozen seafood comes in. So these are the temperature in your freezer. Ice cream, if you really want to teach them very long, it is a temperature called deep frozen, minus 28. And tomato is also finicky. Tomato is the same as banana at about 12, 13 degrees. The pharmaceutical has a range, depends on which type. For the last 2 years, we have one that has a challenge, and it was about the Pfizer vaccine. That one has to be kept at minus 80. In fact, in the transportation industry, we don't have temperature control containers at that range. So in order to ship those Pfizer vaccine, they have to use special, and they were all air cargo containers, not containers used on truck or ship. So these are containers, what we call surface container on truck or ship to ship fresh produce and veggies and things like that. So that ends the part on bits and pieces. The very last part I'm going to talk about is the problems, what happens to supply chain management lately. And this was from my discussion assignment. So that was a discussion forum in my course with the student, and the student puts in their research and comments, and I kind of gathered everything together and put it up as a 10 reasons for the supply chain problem today. So I will share this one with you, and after this, we'll go to question and answers. Okay, so we are sharing this, the top 10 reasons for the current worldwide supply chain problems. Actually, you can divide that into A, B, and C. Part A, this actually has a long-term root. Part of it was globalization. The supply chain becomes very long. Think of your laptop computer. If it is an Apple computer, chances are it is put together by Foxconn in Shenzhen, China. But the laptop computer has the processing chip from, probably it could be an AMD or could be an Intel processing chip. The processing chip could be made by Intel in Texas. So the chip has to be shipped air cargo from Texas to China. Your computer screen could be made by LG in Korea, or could be LG in another plant somewhere in Vietnam. So it has to be shipped from another country over there. And your hard drive could be from another supplier from somewhere else. Just think of that. How long is that supply chain? Because actually your computer could be shipped back to Dallas, Texas, to the Best Buy over there. And in fact, that Best Buy is only 10 miles away from the AMD plant that makes the microprocessor chip. So the chip travel halfway around the world to be assembled into the Apple computer, and then fly halfway around the world back to Dallas, Texas to be sold to you through the Best Buy. It is a very, very long supply chain, and many things can go wrong with that supply chain. And there is also how your suppliers, various outsourced suppliers, how could they handle it? So the second thing is the just in time, because we go into this model of lean production. Everything is just in time. We don't keep a lot of safety stock because inventory costs money. So we just have barely enough safety stock to keep the production line running. So what happened? Well, we have war, we have COVID-19, we have weather situation, we have blocking of the Suez Canal. So the intermediate term, we actually in the supply chain has a very unbalanced flow of world trade. Think of all the containers. They are fully loaded. Most of these are consumer products. The consumer product containers are fully loaded from East Asia. So that will be Japan, South Korea, China, Taiwan, or Southeast Asia. That could be Vietnam, Malaysia, or the Philippines, or it could be South Asia, Bangladesh for garments and shirts and underwear, or your bathroom towels from India or Pakistan. So all the consumer product comes from certain parts of the world. So all those containers are fully loaded. Well, what happened when that container of Samsung large screen TV arrived in Vancouver? It's empty out. So what do you do with that container? Well, you have to ship it back to where it came from, South Korea. What do you ship back? Well, we actually have very little things to ship back. Most of the time, those containers went back empty. So there is totally unbalanced flow. Because westbound from Vancouver is a lot of commodities, potash, sulfur, grain, and coal. And also those cars, those grain cars come back empty from Vancouver to Winnipeg. So if you think of that, the transportation system is highly, highly imbalanced. All the oil tank car that comes from northern Alberta, from the oil sand, they are fully loaded to Vancouver or to the USA. But when they come back to Fort McMurray, they are empty. Think of what happened. So there is unbalanced flow. Manufacture of high-end computer chip concentrated in a few locations. Through the years, besides Intel and AMD, actually there's very few companies that can actually make high-end processing chip. The only big one is TSMC, Taiwan Semiconductor Manufacturing Corporation in Taiwan. That one actually has one of the largest capacity to make it. So basically, there's only less than 5 companies that can make the high-end computer processing chips, which are in almost every automobile, in every cell phone, in every laptop computer. And it could also be in your thermostat as well, your intelligent refrigerator these days. They have microprocessor chips in it. So that being, the source of this is very highly concentrated. So coming to the last 2 years, pandemic, factory lockdown, we have manufacturing disruption. And think of it, it's not only that the Toyota being put together, the Toyota depends on others to make the plastic parts, to make the windshield wiper, to make your Bluetooth component in your Toyota. Well, if any one of those get disrupted, the production line, they cannot complete the car. And you know, actually, lately, General Motors has actually shipped out some of their GMC Sierra pickup truck without some of the microprocessor chips in it. They actually told the customer, we can deliver the car, that you just have to wait and then bring it back to the dealer. We will reinstall it later, because otherwise they can't deliver their GMC Sierra pickup truck. So disruption. The other big thing is, for the last 2 years, until the end of the lockdown, spending of service was greatly reduced. We don't go out to movie, we don't go out to restaurants, we don't go out to sports events, we don't go out to concerts. So people being stuck at home have more money. Where does the money go? You go online and buy things. So consumer purchasing trend actually shot up. Spending on merchandise increased drastically. Increased popularity of e-commerce. So instead of going to the shopping mall, you buy it from Amazon. Well, Amazon relies on the supply chain to deliver you the product. There is increased load on the supply chain, increased manifold. And there's also transportation workers shortage. Average age of long-haul truck driver in the USA is 94 years old today. Fewer young people want to join. One of the reasons is because the pay. The average pay of the median pay of long haul. So this is over the highway, not the pickup and delivery truck driver that drive around the city. The long haul intercity driver. Average salary in Canada is about $52,000. That's the median, okay, for a long haul truck driver. They are paid by the kilometer. And the pay right now is about 40 cents per kilometer in Canada. An average driver drives around 12,000 kilometers per month. That's 144,000 kilometers per year. And then you multiply that by 0.4, and it is somewhere around $52,000, $55,000 per year. And they don't get paid if the truck is stuck in traffic, because they are paid by the mile. So that is not very, very attractive. And this causes the backup at the port. You see the photos at the port of Los Angeles, all these container ships, because they could not unload it at the port because there were no truck drivers to pick this up. Now, the port of Los Angeles and Long Beach, they do have railway connections there. It's not direct, but they do have connections to the Union Pacific and the Burlington Northern Railway system. So that took off some of the containers there for other city in the US. Last of all was the severe shortage of the high-end computer chip. That actually spilled over to the auto industry, to the computer industry. And these were the 10 items that was actually, I worked together with my class, and for the research, the top 10 items that causes the supply chain disruption in the world today. Okay, so this concludes the formal part of my presentation. So the last part will be questions and answers, and I'll try my best. I've been talking for about an hour and 15 minutes now. Okay, so I should stop. And part for questions and answers now. And I'll try my best. I must say I don't pretend to be an expert. I'm just a guy who knows a little bit of everything.
Well, thank you so much, Stephen. I think there's a lot of information there that many of us have not encountered before. So, okay, anybody with questions? Oh, Jim already has his hand up. So go ahead,
Hey,
Jim.
Yes, that's Jim. Go ahead. You got the microphone.
Yeah, I've got my mic on now. Let's see. Oh, let's see. I guess a few comments. I noted that ship for the cars sure reminded me of the moderately large ferries I've been on, the Manitoulin Island to Bruce Peninsula and mainland to Prince Edward Island.
Uh-huh.
Yeah, just scaled up.
Yeah. And if you go to West Coast, Vancouver,
Yeah.
okay, so the BC ferries, okay, so you go from Tawasin to Victoria. So BC ferry actually is a drive-through. So it's the ferry is double-ended, so they don't have to turn it around. You just drive through, and then it's like a huge parking lot there at the bottom.
Yeah, that's exactly the
That's the
design
same
on the two
idea.
that
It's the same idea.
same design on the ones I've been on. I remember 20 years ago or more hearing about this just-in-time stuff and thinking, gee, that's awfully risky. Isn't a warehouse essentially insurance premium against?
The warehouse is the buffer. The
Yeah.
warehouse is actually the buffer. Okay, but now in the warehouse today, what they have at the warehouse is the last buffer to the retail shop. They don't keep a lot of warehouse in between the supplier and the production line.
Yeah.
So let's say Toyota doesn't really have a warehouse for tires or rims or batteries. No, they don't. But Best Buy would have warehouse for the computers.
Yeah.
So that is the buffer for and sometimes what they do is they stock up in the warehouse for the peak season, such as Christmas. So Best Buy will stock it up for those. Yeah. And also in the auto industry, and sometimes they stock it up, but they don't stock up a lot. Is because, let's say, where the auto industry has a model changeover in the summer, and they would shut down for maybe 3 weeks. When they do the changeover, before they do that, they will have some stock up for some of the components ready for the next model year. And that's all they do. But usually it's just in time. And the warehouse is mainly for the retailer, like Hudson Bay or Best Buy.
Yeah, I recently found, okay, I just couldn't find, there just doesn't seem to be a store in Calgary that would actually sell me a battery for my laptop. But I found it wasn't all that hard to find something on the internet, and it got mailed to me. Took a few days.
Yeah.
I don't know where the company is physically located, but I got the battery.
Yeah, you got the battery, Jim, for reasons because the battery is not an item they can sell frequently at Best Buy. Because you've got different models and the year of your laptop could be a few years old. So there's no point in there for them to keep the battery, which is actually, and the battery could degrade if it's not charged up all the time. So they don't want to keep inventory of those. So basically, if you go to Best Buy or go to any of the computer shop and look for a battery, and if your laptop, if it's a few years old, chances are they won't have it. They won't stock it.
Are some of these problems related to why? Are some of these problems related to why they aren't talking about battery swapping for electric cars rather than fast charging?
Well, there's actually some design. There's actually some automobile manufacturer is actually talking about swapping battery.
Yeah.
Now, the way Tesla is built, they cannot, because the battery form part of the structure of the car.
Yeah.
Okay, so the reason is because the battery is so heavy.
Yeah.
If they actually have a frame like a regular car and put the battery at the bottom, it is adding a lot of weight. So what Tesla has done was make the battery part of the structure of the car. And that means that you can't swap the battery.
Yeah. Now, I know that some people are working on metal air batteries, and apparently a lithium air battery would have almost the energy density of gasoline.
Yep.
If they can get close to the theoretical.
Because today, if you look at the comparison chart, it's quite dismal, actually.
Yeah. See also the Wikipedia article on energy density for both energy per volume and energy per mass.
Mhm.
Yeah. Anyway,
Yeah.
I guess I'll let somebody else talk.
Okay,
Yeah.
sure.
Okay, Gavin, you are next.
Hi, Stephen.
Hi, Gavin.
So I was one of the big stories over the last couple of years in supply chain management and logistics was the Ever Given stuck in the Suez Canal for 3 weeks.
Yep,
if I remember
last
correctly.
year about this time.
Yeah.
Yeah.
So I was wondering if you could give us a flavor of how long it took to catch up or untangle that mess, and what did that look like?
To untangle that mess, that was a long story there. Now, you know, that was a finger pointing at that event. Really, every ship that sails through the Suez Canal has 2 Egyptian pilots on it. So actually steering the ship through a port or a canal, the control is given to the pilot, not the captain. Okay, so when the ship got stuck, whose responsibility was that? The Egyptian Canal Authority points finger at Evergreen, but Evergreen points finger back at the Egyptian Port Authority, the Canal Authority, was that you guys, the 2 pilots, you are in charge. And what really happened there was a sandstorm, and the Ever Given is one of the large container ship, fully loaded. So you look at one side of the ship, the total area, square footage, is huge. So when the wind blows, the ship will be got pushed to one side. So they don't want the ship to touch the bank on one side. So they steer the rudder slightly to the other side. And they also, because they can't see, they slow down the ship. And you know, no, Gavin, you are an engineer, you know fluid hydrology mechanics. When the ship slowed down, the effect of the rudder actually diminished drastically. So actually, when they turn the rudder, the effect of the rudder isn't that much anymore. The effectiveness of the rudder actually diminished. And they probably oversteer the ship a little bit, and they try to steer it back, and bingo, the ship actually, the bow of the ship got stuck first, and then the stern got stuck as well. Now, how they got that out, there were several scenarios. They were going to send in other container ship to unload the Ever Given, to lighten it. And they were also waiting for high tide. None of these worked. But actually what saved them was that fleet of tugboats from the Netherlands. There were the tugboat that was sent from the Netherlands, and the Dutch were very good at this type of thing. Because the Dutch built dikes and dams, they were experts. And all those tugboats actually came from, mostly from the Netherlands. And they know how to do this, and they managed to pull the ship out at high tide. And that was, I think, it stuck there for almost a week. And that was a big, huge backup. Part of the aftermath of that was some of the containers were positioned at the wrong place in the world after that, because the other ship went through the Cape of Good Hope. And was a long, long trip. And some of the containers were actually positioned at the wrong part of the world after that. Did I answer? I don't pretend to be an expert in everything, so I just know a little bit of everything.
Yeah, I was just wondering how long it took to get that logistics sorted out. Not getting the ship unstuck, but how long did that backup of a week take to clear?
Oh, the week? No, that was longer than that. That was much longer than that. That was, I think they said it was more than 4 weeks for the logistics to clear up. Because there were quite a few ships waiting at the Red Sea, and at the other side of the Mediterranean Sea, there was quite a few ships there. And one of the effects of that is also there was a lot of loss. A lot of the containers of the ship, temperature control container, was produce on it as well. All those produce went back, okay, when they got stuck there. They passed the the best, the perishable dates on those produce. So, yep, actually, lots of things were lost.
Oh, thank you. So, okay, Don, it's your turn. Do you want to turn your mic on?
Yeah,
Hi,
hi.
Don.
Thanks for this. This is very informative. My question or my concern, I guess, is with the trucking industry. What can be done to make the trucking industry more palatable for young people? Like, is it just too over-regulated? Like, is it too?
It's not really too regulated. It's just the salary is way too low. Now, I'll give you an example. The average truck driver, especially if the long-haul truck driver, are the ones who makes more money. But if you were a long-haul truck driver and you drive between, let's say, from Vancouver, bringing the fresh produce in the summer, from Vancouver to Abbotsford, all the way to Toronto, you'll be on the road for about 6 days. And then you lay over in Toronto for a day and a half and take the trailer, and hopefully you have a backhaul load. Otherwise, if you're going back empty, you won't make money. So hopefully you got something on your trailer for a backhaul back to Vancouver. Well, you are away from home for the better part of 16 days now, by the time you get back to Vancouver. Have a few days of rest, and then you go back again. Now, if you were a young fellow in your 20s, you want to start up a family, are you going to be a long-haul truck driver? It's not something appealing for the young people these days at all. Okay? And the pay for about 40 to 45 cents per kilometer, if you are moving, it's not appealing. It's only about $52,000 to $55,000 median income right now. It is very low. So either there are several things I have been thinking about and talk about. The wage have to go up, definitely. Some of these truck drivers are what we call owner driver. They own their own tractor and they drive for somebody. So let's say Walmart. Walmart have owner driver set up. So the owner owns the tractor, Walmart owns the trailer. And they pay the driver the cost of operating the tractor together with his salary. So that is much, much higher. But then the owner is responsible for the maintenance of the tractor and the fuel and the insurance in that case. But they pay them much higher. So the owner driver is a small businessman in that case. So some of those drivers, those are more appealing, especially some of the drivers who are in the 50s. When their kids are already teenager or they are empty nester, they own the tractor with the sleeping quarter at the back. And what they have is husband and wife team. So they could be on the road and one of the spouse go for rest or sleep and the other spouse drive. In fact, we have a lot of these owner driver spouse team. So that is more appealable for the older generation that can do it. So the first thing is, of course, the salary is way too low.
Is it a matter of getting more of these older people that can actually, so they don't mind being away from home, like a husband-wife team or a couple team? Yeah, that's probably where the answer lies, is getting making that palatable for that.
Yeah, and actually today on the road, a lot of the drivers are in the 50s and 60s. There's a lot of drivers and even some 70-year-old guys are still driving.
So there is an adage, once a trucker, always a trucker, you know?
Yeah, that's right, a trucker. So but when we say the median age is 49, this is actually very skewed, okay? There's a whole bunch of young people there, but they don't last very long. And then you have a whole bunch of people in their 50s, 60s there as well. Okay, any other questions?
Okay. Dee Dee, unmute.
Hi.
Yes, I put my hand up before Don's question, and that was my question, but I didn't really hear an answer. But I just wanted to thank you for your presentation. This is not something I'm interested in at all, and you made it interesting. So thank you for that, and I learned some things tonight. So I'm going to leave right after I hear the answer to this question. Why don't they raise those salaries for those truckers? Like that just seems obvious to me.
It seems obvious. Okay, now we got to go back into the consumer. How much are you paying for a pound of banana today? Now, it's been 79 cents at co-op for a long time, banana. If you raise the wage of the truck driver, you are not going to get 79 cents banana anymore. You probably have to pay maybe 90 cents now.
Okay, I understand that, but prices are going up on groceries as they're going up on everything. So they're going up. So obviously none of that is going to the trucker, and a few more cents going up. I mean, if we don't have bananas at the store, if we can't get bananas and we really want them and need them, well, 5 more cents.
Well, I agree. We should be paying the trucker more because right now it's way too low. And I'll give you an example. In the transportation industry, CP Rail just went on strike on Sunday morning, okay? And then they basically went back to work 2 days later. Now, the median wage of a locomotive engineer at CP Rail today is $120,000 for a locomotive engineer. The qualification is high school graduate. 6 months on training on the simulator and in classroom about transportation rules, regulation. 6 months as an apprentice. When you get your license, you'll be a low-level locomotive engineer. You start at about $85,000. The top paid locomotive engineer is about $160,000 a year right now. It's better than a professor. Okay, so if you think about that, between the railway and the trucker, it's a big, huge disparity there. And for a locomotive engineer, the life is much better than the trucker because the locomotive, the way train runs is they run within something called a division. So Vancouver to Hope, BC, you know where Hope is? So from Vancouver Lower Mainland to Hope, BC is one division. So they take the train, the conductor and the engineer take that train to Hope. Then they switch crew. Another crew take it from Hope to all the way through past the Fraser Valley to where the top part is Kamloops. Then they switch crew at Kamloops. So the crew that took the train to Hope take another westbound train back to Vancouver. So the crew is never far away from home. They may stay overnight at Hope. That's it. And they're not paid by the mile. They are paid by salary. So if the train got stuck on the siding for an hour, they still got paid. So you see, there's a big difference there. So a lot of people want to work for the railway. Hey, it's not bad. It's actually very good pay. And they even go on strike, even they make $160,000 a year, they still go on strike. Well, compare that with the trucker who have to be away for 16 days. There is a huge, huge disparity there.
So I am going to say goodnight because I had another Zoom right before this, but I just wanted to make a comment about that. It's surprising then that there were so many truckers getting in their trucks and heading to Ottawa. But on the other hand, maybe this is why they were so pissed off.
I think that's one reason too, because they are really pissed off. Tell you the truth. Yeah.
Wow.
Okay. Okay. Good night.
Thanks, Steve. Okay, Donna.
Hi, Donna.
Hi, Steve. Can you hear me?
Hi, Donna.
Yeah.
Yeah, thanks so much. That was really wonderful. So much stuff that I had no clue about. And you know what was interesting was that Ukrainian cargo plane that took a train. I mean,
cargo plane that
got
destroyed.
Cars, or was it even the locomotive that pushed it out? Was it just cars?
No, it is a train that goes into a cargo plane. Actually, they ship the train by air cargo.
That's just crazy to me. And I can, on your little graph, energy efficiency, to me, it just seems like that would be really inefficient because of the weight.
Yep, the weight. Now,
like
that was a flight for promotion. That was a promotional flight for that. Yep. That is not regular. They show it how the plane, the capacity of the Ukrainian Antonov plane, how good it was. Now, but sometimes for certain reason, actually heavy goods have to ship by air cargo. And that actually happened in Alberta before, in Edmonton. They have an oversized oil distillery. I think it's a distillery tower of something, okay? So it was built in South Korea, one of the oil distillery tower. It's too big to put on a truck or on a train because the diameter of that is way over. I think they said it was like 5 meters or 15 feet, 16 feet diameter, and it weighs like 60 tons for that thing. Well, they made it in South Korea. They want to ship it to Fort McMurray. How do they do that? They can ship it on the railway. They can ship it on the plane, on the road. They actually air freight it with an Antonov air cargo plane. From South Korea, they actually flown it to Edmonton. They unloaded in Edmonton, and then they used a special truck, and they went on, I think, Highway 63 at night. So through many days, they pulled that thing. So yeah, because of special requirement, you can't go it by sea, you can't go it by land, then you go it by air. It's expensive, but there's no other way.
We just have too much stuff that, we don't do. But can I ask another quick question?
Sure.
So Mike Robinson, the one that we all know, when he was young, he used to work in grain, and he told me that the train would come in, the cars would come in, and somehow it would tip so that they could pour the grain out the car doors.
Yeah.
Do you have any picture?
There was way back about 30 years ago. It's very long time ago, back in oh my goodness, it's already 40 years ago.
Yeah.
Back in the early 1980s, when I first joined CP Rail, they were running short of what we call the hopper car. So those were the type of cars you see today, which they unload the grain at the bottom. So they got open the chute at the bottom, and the grain comes out at the bottom. They were short of those. So what did they do was they used regular box car and line the box car with cardboard inside. And then what they do is they tilt the box car to one side and load it with grain. And then close the door. Now it's not as efficient with the hopper car. And when they unload it, they tilt the box car to the side as well, and then open the door and crash the cardboard, and all the grains come out.
Oh, so it's not a mechanical thing with the train. They physically tilt it.
But no, it's not. It's actually, no, it's partly mechanical. What they did is the track at that point can tilt.
Oh, okay.
They can tilt actually at Thunder Bay, there is a facility there at Thunder Bay. What they do at Thunder Bay to unload a coal train. So the coal comes from Sparwood in Vancouver. So they have an entire train of coal. So those coal cars you see, and they don't actually unload the coal from the bottom. It's called a gondola. So it's an all open top coal car. But those cars are designed in such a way so at one end, the coupler can rotate. So you can rotate one car at a time without breaking the coupler. So one coupler is 360 degrees rotated. So when they get to Thunder Bay, Ontario Hydro and Howard power plants right there, they unload the coal car. And what they do is one car at a time, there is a rotating, it's like a circular thing. The coal car goes into on the track, and the circular thing rotate. The axis is actually right at the rotating axis of the coupler. So the coal car is flipped 180 degrees. So all the coal starts come right down, and there's underneath, deep underneath, there's a conveyor belt. And the conveyor belt goes up underground further, and then there is that thing that conveyor belt throw all the coal into piles there. So the conveyor belts can move in different positions. And basically they can unload an entire coal train in about 90 minutes.
Wow.
Wow.
They can do that. Yeah, with the facility there. So actually, if you look at supply chain, there's a lot of other things. It's not just the transportation equipment. You have to think about the facility, the infrastructure. There's a lot of other things there, which of course tonight I did not mention. I did not talk about those things. Yeah, there's a lot of other things there.
Very, very interesting. Thank you, Steve.
Yeah.
Okay, Brent.
Hi, Brent.
Hello. Yeah, excellent presentation. Really like that, Stephen. Many moons ago, I was actually looking at becoming a professional purchaser. So I sort of had a small amount of that, like I was focusing on just in time at the time and stuff like that. But anyways, speaking of just in time though, and the weaknesses that have been shown up recently with just in time, and also the international transportation requirements, is there pressure to go back to local supplying, or is that just going to be a temporary situation right now?
There is. So we have this term called offshoring in supply chain and international business. So offshoring is making your computer chip in Taiwan. That is offshoring. So let's say this is Hewlett-Packard, and they got a plant assembling Hewlett-Packard computer in California, and the chips come from Taiwan. That is offshoring. Now, in fact, Intel is building a new chip plant, let's say in Texas. That becomes a term called nearshoring. So we are going into nearshoring models now. So the United States, especially with Joe Biden, say, buy American. So the idea is cut down the length of the supply chain and go for nearshoring.
Does that worry countries like China and?
Oh yeah, because there are so many manufacturing plants that is leaving China now.
Oh,
they realized actually, Adidas left China, a few others, Adidas, and then who else? Another sporting running shoes manufacturer besides Adidas, Nike. Nike actually left China. Okay, so there is, because of the US trade policy, and part of it is it may not necessarily be offshoring. It's just there is the cascading to the cheapest also, because wages in China is rather high compared with Bangladesh now. So they are going to where the water goes to the bottom right now as well.
Does this also help out Canada as far as being a near local supplier to the States?
It does.
Yeah.
Canada being very close to the United States, so we know that as long as we don't have truckers blockade, that's fine. That was one of the things that actually ruined the reputation of Canada as a very reliable supplier. Actually in Ontario, yesterday they announced a big plant in Windsor, Ontario, to build the new lithium battery for electric car. And that was a joint venture between, I think it was Samsung or LG, one of them, and another company.
Was it Stellantis?
Probably. So it's one of those from South Korea and Stellantis. So they are actually building a huge factory right at Windsor, which is across the river from Detroit. So that is nearshoring. really, really nearshoring. And of course, Windsor is not far away from those plants in Toronto. So there is the huge old Honda plant in Elliston, Ontario, which is just outside of Toronto, and that big Toyota plant in Cambridge, Ontario. So those are two huge Japanese transplants there. And of course, Chrysler have plants in Windsor, and Ford have that big plant in Oakville, Ontario as well. So that is basically nearshoring now.
Great, thank you.
So Stephen, I have one question.
Yeah, sure, go ahead.
When you were working in the field, what was your biggest challenge?
My guest challenge is juggling many balls together at the same time. You have to learn how to juggle, okay? Because so many things can go wrong and you don't expect it. The little things, I'll give you an example. We were involved. I never thought of things could get so complicated. So I was the transportation service manager. I developed the transportation service. So which route, which train, and which are the customer we service, what type of rail car we use. And I work out the power to weight ratio. Basically, how many locomotives do I need for that train? So I did all those things. So do the train run, and then we have to find time slot for that train to meet the customer delivery date and requirement. So all these things, while you are competing for track time with others, the coal train, the potash train, the grain train, and all these other things. So you kind of juggle and you negotiate with the heavy haul guys who ship the coal. Well, I need track time for this train to go to time slot. But then, well, the coal train, they go slow. They are too heavy. And the train, the guys that ship oil, they have a speed limit of 80 kilometers per hour because it's dangerous commodity. But my stuff are all consumer product. So my customer could be, let's say, Hudson Bay, and they are shipping garments and fashion. Well, they need that to be on time, the sale, time sensitive. So the container train could go 110 kilometers on the straight track of the railway, same as the truck. Well, your coal train is blocking in front of me, and I can't pass you. It's not a two-lane highway where I can just steer my steering wheel and pass you. You have to go to a siding and let me go past you. So if you think that, there's a lot of juggling and negotiation to get it done.
Wow, fascinating. Okay, Jim, do you have another question? Jim?
Mostly a comment. Yeah, let's see. I guess I missed a bit because my internet connection was weak. But anyway, I think I'd like to mention there's a podcast I listen to, Science for the People. One of the most recent ones is about this same topic. They covered a few things that Stephen didn't cover. One interesting was the pilot getting onto the ship to take it into port.
Yep.
And so anyway, it's called Science for the People, and look that up. And let's see. And this book I read recently called Shorting the Grid. One of the things she complains about is the reliance on just-in-time gas, which makes the grid unreliable. Yeah, anyway. Shorting the grid. Anyway.
Thanks, Jim. Bruce, do you have something?
I was going to say that some time ago, I worked on a multimodal transportation study at the University of Pittsburgh. It was quite interesting. The underlying power of how transportation is undertaken, at least back then, was purely financial. And for example, I went about and interviewed various leaders in transportation, ranging from rail to barge transportation and air. And they had all these acronyms. Heard of piggyback? Well, there was
of course, piggyback. Yeah, the trailer sitting on the
and
car.
birdie back and all those.
Yeah.
And it was quite interesting that the underlying issues were all based on the profitability issues, and the profitability then was the attention to that was given essentially by Wall Street and Bay Street, you know, that, and nothing else really counted. So, and that was at a time when the area that I lived in had enormous tonnages of transport of coal by rail and by river barge. And then right after that, I worked on a project where the idea was to, and this was fairly tricky, it was to schedule the arrival of coal from at least 12 different mines located within, you know, roughly 60 miles. The assay of the coal varied. So the idea was to be able to get the right mix of coal in order to make coke, which was destined to making steel, or iron and then steel. And it was the largest in that area. It was the largest coke plant in the world. And so they were bringing, you know, 40 or 50 barges of coal every day. And the barges would come downriver and upriver and were ordered in terms of the analysis, the assays of the type of coal. But unfortunately, this very large coke plant, which actually still runs, was upgraded to be to make use of all the byproducts of coke making. You know, many gases and liquids driven off when you make coke, but there wasn't a sufficient market for all of that. You could make fibers and dyes and all sorts of things, but there's such a shift that there's no clarity in where globalized trade is actually headed. I mean, almost anything that's made anywhere could be made in some other place. And the olden times of bringing the raw materials to make things is almost beside the point now. When Henry Ford established the River Rouge plant in Michigan, you know, he was bringing every fundamental component, you know, iron ore, limestone, coal. He was bringing vanadium from Colorado and just all sorts of things. But
so actually,
they didn't have computer chips then.
I know. Henry Ford, when he built the Ford Model T, actually almost all the components were made by Ford. For today, a typical car, 75% of a car is not made by the car manufacturer, because If you just look at the car, the battery is not made by them, the windshield wiper is not made by them, the tire is not made by them, computer chips not made by them. 75% of cars not made by the car manufacturer, because we all get into specialization. And then it's also the economy of scale. The car manufacturer cannot make the tire at the same price as Goodyear or Michelin can, because they can sell the tires to many car producers. And if you were to think about if GM were to make tires for GM only, their volume will be very, very small. So yep, today, because of the globalization and outsourcing, and one of the reasons is because of specialization. They are Michelin, they specialize in making tires, and they are very good at it.
Oh, so interesting.
Yeah.
Well, we are a few minutes
Well,
after
I think
9, and
9 o'clock.
this has been fantastic. Does anybody have any other comments before we wrap up here? Okay.
Hey, good. I hope you learned a lot.
Absolutely.
Get a lot of information.
Thank you so much, Stephen. No, this was fantastic. And again, there's never been a more appropriate time to learn about this. So we really appreciate it very, very much.
Well, thank you.
Okay.
And so, yeah, we can stop the recording and post it somewhere.
Donna, what was that?
So when are you going to give the course 102?
Actually, Supply Chain 101. No, we actually don't have such a course. I made this up. The first course is actually LSTM 2201 Introduction. It's a second-year course. So I just made this one up called Logistics and Supply Chain 101.
No. I'm just saying, we want more. We want more.
Yes, we want more. Oh, well, thank you so much, everybody. This was really, really terrific. And thanks, Stephen. And
my pleasure.
Everybody, be well and don't work too hard.
Okay, I will try not to, but I have a quiz tomorrow.
Oh dear. Well, take care every night. Good night, everybody.
Good night, everyone. Good night.
Night. Okay.